So in section 9.5, we're going to look at test of two variances, and we're going to start looking at a new distribution, which is going to be the F distribution here. So a couple of key characteristics from here is that the F distribution is not symmetric like our normal distribution. And as our F statistic, or I should say as the sample sizes end up getting larger, it starts looking more approximately normal. And we'll see that it starts at 0 here as opposed to 0 being right in the middle as our normal distribution there. A couple of things here that we do need is that even though the F distribution is not normal, the samples from which they come from need to be normally distributed, and then the two populations also have to be independent. And so here we see just some formulas for that. Again, the test statistic here is really just the ratio of the two variances. So we could see that they'll simplify there. And then our distribution, again, dependent on the degrees of freedom, which in turn means if you have the larger sample, your degrees of freedom also increase. And as we had mentioned, as that happens, your distribution starts looking more and more normal. So it's skewed towards the right for something with smaller degrees of freedom right here. We could see this curve. And for something that has larger degrees of freedom, or again, larger sample size, we see that it starts appearing more normal there. Okay, so let's look at an example here. And so here we are looking at, and let me back up a tiny bit right here. Okay, sorry about that. Okay, so two college instructors are interested in whether or not there's any variation in the way they grade math exams. So they each grade the same set of exams, so 30 each. And then the first instructor's grade has a variance of 52.3. The second has a variance of 89.9. And we're going to test the claim that the first instructor variance is smaller. So again, note that we're not looking at means, we're not looking at proportions, we're looking at variances here. And so let's go ahead and go with our four-step process. Let's look at our first step here, which is getting the null and the alternative. So HO and HA are null and alternative here. And we could see in this case that we're going to be comparing variances, and we have two samples. So we're going to have sigma sub 1, that subscript here is going to be for the first group, and then we're squaring it because that makes it a variance there. And the claim is testing that the claim that the first instructor variance is smaller. So we're going to go less than, and that's going to be our claim. By default, we should actually have equals right there. Okay. So let's go to our next step here. Data and stats. And so we see that the sample sizes were the same, so 30 for each. And then here we see the variances for each of the groups. So I told us the first instructor and the second one here. So 52.3 and 89.9 respectively. And the distribution here, it's a F distribution, and it's going to be dependent on the degrees of freedom. So that means we have 29 and 29 for each of those groups there. All right, let's look at the third step, our calculations and graphs here. And again, I try to do this a little bit skewed off to the right, not exactly symmetric here. Maybe let me reduce that a tiny bit. And so this is a F distribution. So again, we're going to label that F, and then we are going to label this here right at 0 as well, when we're starting. And this is a left-tailed, because it's less than here. And so we're going to go ahead and shade over here towards the left. And so this region right here is going to be our alpha, our significance level of 0.10. Again, this is the critical region. And corresponding F value here is what we call the F critical value. Okay, so there's kind of our picture. So let's go ahead and try to do some calculations here. And so we're going to go in our calculator under test, and we're going to find our two sample F test. And so this is what I inputted here. And so notice that it's asking for the standard deviation, not necessarily the variance. A lot of times we could also test the standard deviation here just by getting rid of the squares here. And so notice my standard deviation for these is the square root of the variance. So that's where I'm getting that 7.23 and then also that 9.48. And you could go ahead and just plug in the actual square root of those values, and it'll calculate it for you right in that menu there. Make sure we're under stats, we're doing less than, and then our samples are 30 each. And so if we did this by hand, the F test statistic is the ratio of both of the variances. We would end up with 5818, and that's what our calculator gives us here. So that F value, again, is always, that's going to be the test statistic. And then it's giving us a P value here, so the area associated with that. So let's see if we could sketch this here. Notice our P value is less than alpha, so it's going to be contained. So 0.07. 5.3 is less than 0.10. So my p-value is going to be contained. Where exactly? Not sure, but probably somewhere about there. So that's where that F test statistic would be. And so that region in here is going to end up being our p-value. Okay, so there's kind of our image for that. So again, if you fall in that critical region there, that means we end up rejecting the null, right? That probability ends up being very, very small, so we're going to end up rejecting. So let's go ahead and go to step 4. Our discussion and conclusion. P-value we said is less than alpha, so we reject the null. Again, this test is always for the null. And then by default, we do not reject the alternative. And in this case, since the alternative is my claim, we're going to say do not reject the claim. All right. And since the claim is our alternative, we are allowed to use language saying that we support or do not support. It's when the claim is the null that we're not allowed to use that. That's when we use our language that we warrant a rejection. So do not reject the claim. We're going to say something along the lines. There is sufficient evidence to support the claim that, and you could just copy it word for word there, that the first instructor's variance is smaller. So here's a nice example of our F distribution here, our two sample F test comparing two variances. And again, this could also be used to compare standard deviations. If you notice, this is how it's listed on most technology, that they'll actually have the standard deviations there. And you could see it again right here.